Hey everybody, today we're going to be taking a look at writing polynomial functions, and that means rather than us doing all the work of factoring and solving, we're given a situation and we need to write the equation for it. So you're going to need your notes, a calculator, and something to write with, of course. So if you recall back to what we've done in previous chapters, we learned about the intercept form for a quadratic function. So we learned about understanding how we write x-intercepts or how x-intercepts are related to these solutions. In this section, we're going to do that, but with polynomial functions, we're going to have more factors or more pieces to think about, because they have more x-intercepts than a typical quadratic. So here's our first example. Go ahead and write this one in your notes. You don't have to draw the graph, but let's write down that key information there about the graph. So we're to write the cubic function whose graph is shown. Leave our answer in factored form. As you see there on that graph, there's some key points that are being listed there. We see x-intercepts at -3, at 1, and at 4. And there's also this random point down here at 0, -4. That's not an x-intercept. It happens to be a y-intercept. But for our case, we'll think about that as a random extra point that we're given. Now, knowing what we understand about writing these functions, and there's a general form to get this started. So the general form looks like this. Y equals A. This is that value that we solved for before with quadratics, but now we're just doing it with polynomials. And then each of these are factors that we're going to write to figure out or to reflect actually those x-intercepts. So if we think about it, if I need an x-intercept at -3, at 1, and at 4, that's where I'm going to start. I'm going to start by thinking about what factors give me these three solutions. And I'm going to use that to write what goes in these parentheses here. If I need a solution at -3, then one of my factors had to be x plus 3. If I need a solution of 1, then one of my factors has to be x minus 1. And if I need a solution of 4, then my factor has to be x minus 4. So first I'm plugging in that x-intercept information. After that, we go to our random point. Our random point was 0, -4. The 0 is in the x and the -4 is in the y. So everywhere in that beautiful formula we have an x and a y, we're going to plug those numbers in. So the 0 goes where the x is, the -4 goes where the y, and then we go ahead and calculate. Inside my parentheses there, 0 plus 3, 0 minus 1, 0 minus 4. If I figure all of those out, I get 3, -1, -4, and if I multiply all of those next to that a there, it becomes 12. So -4 equals 12a, divide by 12, and you get -1/3 for the a. So then all we need to do is finish up our equation here, or our function, and plug that a back in and finish writing our factors. So y equals -1/3 where the a is, and then x plus 3, x minus 1, x minus 4 to make sure that we have those x-intercepts. Okay, so this is what we're talking about doing today. Let's do one more. Write a cubic function whose graph passes through these points. Leave your answer in factored form again. So looking at this list of points we have here, there are 4 points. 3 of them are going to be our x-intercepts and 1's going to be our random point. Because these 3 all have 0 for the y value, these are the x-intercepts. So my x-intercepts are at -2, 0, and 1. My random point is 2, 1 then. And we just do the same thing we did on that last example. We'll start with the general formula, and we're going to think about, in order to have these x-intercepts of -2, 0, and 1, in order to have those solutions, we need to have factors of x plus 2, x minus 0, x minus 1. Those are the 3 factors that I would solve to get these 3 solutions. After I plug that information in, then I plug in my random point. Random point is 2, 1. That's an x value of 2, a y value of 1. We'll go ahead and plug those in where the x and y are. And then we figure out those parentheses. Okay, what's going on inside of those? Well, I have a 4, a 2, and a 1. And if I multiply all of those, I get 8. So 1 equals 8a, and I'll divide by 8, and a is 1/8. So to finish up my equation, y equals 1/8, x plus 2, x minus 0, x minus 1. Or we can use and take that x minus 0 and turn him into just a regular x you see right here, because x minus 0 is still x, and then we don't have to write the minus 0 there. So either way you write your equation, our whole end goal is solving for a and then using that in our function to reflect how that polynomial function is going to act. Okay, so this is our goal for tomorrow. Thank you for taking good notes.